All right, so to introduce logarithms, let's look at this question here. What exponent of 10 results in 500? And another way to write this question is if it said to solve the equation 10 to the power x equals 500. So how do you find that? You could do some trial and error. You could do 10 to the power 2 and get 100, or 10 to the power 3 would be 1,000. So it's going to be somewhere in between 2 and 3. But whatever this x is, whatever the answer to this question is what we call the logarithm base 10 of 500. And you write it out like this. Log with a little subscript of 10 below next to the G there, and then with 500 written on the same line as the word log. So that is called the log base 10 of 500. Now, another way to say this is that if log base 10 of 500 equals x like this, then 10 to the power x equals 500. And so this is going to be what we always do with logarithms, is take them and write them in what we call logarithm form, where the output is the result of the logarithm, or you could also write it in this exponential form. But the important thing is that the result of the logarithm is that means the input into the exponential function. It is an exponent. So in other words, a logarithm is an exponent. So what if we want to find this? Well, thinking about what x could be, we could say, well, maybe 10 to the power 2. Well, we know that's 100. That's too small. That's not 500. And we know that 10 to the power 3 is 1,000, and that's too big. So that means that log base 10 of 500 is somewhere in between 2 and 3. And if you wanted to find out what it is exactly, one way you could do it is by graphing on your calculator. Here I graphed y equals 10 to the power x, and also y equals 500. So when you go to the graph, it looks like that, and you can use the intersect method like normal to find the intersection point, which is about 2.6897. So that gives you one way of estimating logarithms here, is by graphing the exponential function and also graphing the result you want to get, which is the input into the logarithm, and seeing where they intersect. But that's kind of tedious. There's another way to do it. You also just have a log button on your calculator. So if you just press this log button, that means log base 10. And so if I want to find log base 10 of 500, it would just look like that. And that's what you get, is the same result. So whenever you do this with your calculator, remember that there's like an invisible 10 when you just press the log button, and that gives you the same result. Here's a general definition of this concept. Take a moment to pause it and write this down, of course, but when you're ready, here's my explanation for it. So we say the base b logarithm of x, written log base b of x, is the exponent to which b must be raised in order to yield x. So what we were talking about here was x was 500 and the b was 10. So to what power did we have to raise 10 to get a result of 500? The power was 2.69. 10 to the power 2.69 will yield the x result of 500. And so let's think about that here. Also, you might be confused by how this x here is a different thing from this x here. This x here is the result of the logarithm, but the y was the 500. So this is kind of confusing, x and y here, if you're using the same notation for both things, but they're different. Okay. So anyways, let's look at this example. We want to know log base 3 of 9. So the result here, whatever this ends up being, is the exponent to which 3 must be raised, because the b is 3, to get a result of 9. So what should that be? 3 to the power 2 will work. So that means the result of the logarithm is 2. Same idea here. With part B, we want to see the log base 5 of 125 is the exponent, the power, that you have to raise 5 and get 125 as a result. So what would that be? Well, 5 to the power 3 is 125, so that means the result of the logarithm is 3. So here it's a little bit trickier. We want to see the base is 4, so that means the base of the exponent should be 4. What should the power itself be, the exponent be, to get a result of 1 over 16? Well, this is the same as 1 over 4 to the power 2, so that means the exponent here could be negative 2, because 4 to the power negative 2 means 1 over 4 to the power 2. So that's that. And with part D here, we want to know 10 to what power gives you a result of the square root of 10. And if you're thinking, oh, the square root is the same thing, because there's like an invisible 2 there, that's the same thing as the power 1/2. You're right, so that means the result of the logarithm should be 1/2. And another way to do this is just take your calculator. Because your log button on your calculator just means log base 10, you can just take log of the square root of 10 and check that your calculator gets you 0.5. So that works. That agrees with the way that here where you got 1/2. Alright, and here is a couple for you to do, really similar to that last example. So here's your place to pause it and try it yourself. Here's what I got. Tried to think of the result of the logarithm as the exponent that you raise 3 to get 81, and 3 to the power 4 is 81, so the result of the logarithm is 4. Likewise, 10 to the power negative 3 means 1 over 10 to the power 3, which is also known as 1 over 1,000, which is what we wanted to get, so that means the result of the logarithm is negative 3.